Hello, in this episode of Exploring Rust, we're going to take a look at box, which is a way of storing things on the heap, and it also has other uses, apparently. So if I create a variable here, I'll just call it value and set that equal to 5, and then we can do print line value, put in the speech marks and that and this. That ought to work. When I run it, of course, we get 5. Now this 5 value is on the stack, which you probably know is a relatively small area of memory, maybe a few megabytes. It's used for storing the values of local variables and also recording which function calls which. However, we can put it on the heap instead, just by wrapping it in a box. So I have to do box : new, and that constructs a box. And now that value 5 is on the heap. In other words, the whole rest of your computer's memory, it's using that instead of this small area, the stack. And if I run this, it works exactly as before. Apparently, the reason this works, even though here value is now of type box of I32, is that box implements something called a deref trait, which means that when we try to use it, it's automatically dereference. We automatically get the value out of this box. Now this isn't really any use with integers, but we can also use it, for example, with arrays. So if I say I'll call this values and set it equal to, now let's see if I can remember the syntax for creating an array by specifying a number of values. I think if I put something like 7, semicolon and 100, I think that will create an array with 100 values in it and each of them set to 7. So to check, let's output values 5 maybe. Let's try that. I put value 5. I've actually got a bit of a cold and my head's not fully right, but I'm going to try to get through this. I've actually already created the article for this and I've run through this code already, so I'm comparatively sure about what I'm doing. Yeah, there we've got a 7. Okay, so they should all be set to 7. And of course, if we make it mutable, we could set values with this syntax as well. Now, this array could potentially be really big. We could like 10,000 in there or whatever. But if you're going to deal with big arrays, you don't normally want them on the stack because it is possible to run out of stack memory. Whereas with the heap, there's so much memory that unless you're doing something really crazy, you're not likely to run out of memory. However, what we can do is wrap this in a box. If I say box : new, put some round brackets around there, and let's try to run that. Yeah, it still works. So now we've got an array on the heap, which is potentially quite useful, and you see that we don't have to do anything special to get the values out of that box. Let's try to get the size of this values element. So I think, again, I want to print it, and let's put that in there. And I want standard mem size of, maybe something like that, and I need sort of diamond brackets, round brackets there. I suppose it's a function call, and then here I put the thing that I want the size of. Actually, come to think of it, I can probably only use this on types. Can I use it actually on a variable like this? I'm not completely sure. Let's try that. Yeah, it doesn't like that. I wonder if I put a underscore in here. If this doesn't work, then I do have a use for size of later on, which definitely does work. Just want to try this out now that I think of it. Yeah, I don't know how to get the size of a variable, so let's scrap that. But what I would expect to see is that this values is, maybe it's 8 bytes or something, because this is now a kind of a smart pointer. So it's just storing an address, which is the location of this array, rather than this variable now referring to all the data itself. So, oh, by the way, I've skipped a section in the Rust documentation that's just about using cargo in various interesting ways, because that's not related to coding, and I really want to get on with understanding Rust code itself. So I'll probably come back to that, but I'm going to leave that aside for now. So we'll use this size of thing later. But the Rust documentation at this point, it goes through another example of how you can use box for referring to something directly. And at the moment, I can't see much use for this, but I think it probably does have much greater use than is mentioned in the documentation at this point. So I'm just going to go through the example that's in the documentation. And this by itself is some useful practice with Rust. So if I want to create an enum, let's say I want to create an enum called fruits. I believe it's like this, and then we can have apple and banana. That should probably work. And then I should be able to do let fruit equal fruits : let's say apple. And if I try to run that, hopefully that will work. Now I've commented that size stuff out. Banana is never constructed. Yeah, these look like just unused variable warnings. I have to make those shut up. Let's put up here a hash, exclamation mark, couple of square brackets, allow unused. Otherwise I just can't see what's going on with all these warnings. So right, let's try that again. Hopefully there were no errors there. Yeah, that's fine. Okay. So we've been through enums before, and you'll recall that they can have values associated with them. So here I could put, for example, I32. Let's have a couple of numbers like that. And then, so this code still works, surprisingly, but I can supply a couple of numbers with apple now, not with banana. So here I could put, for example, 7, 8, and then this variable will store those values. Let's try to get them out. So to get them out, I could use a match. I could say I'll just use values again, redeclare that. Let values equal match fruit. And in the case where I've got fruits, : apple, and let's call this X and Y. So in that case, I could, for example, just return them as a tuple like this. And then I could put, in the other case, so I could now list fruits, banana. I've got to list all the possibilities. Or I could just put other. And in the case that we get something else, of course we could have more than two options in here. Let's just return a tuple of 0, 0. And that, I'm sure, has to have a semicolon. And then we could print this out. So print line, exclamation mark. And let's have a couple of these. And we've got values.0 and values.1 because this is now a tuple, and that's how we access tuple values, which is a little strange, but private field. Oh yeah, because I just put value instead of values. Okay, try again. Yeah, it works. We've got 7 and 8 coming out down there. All right, so I'm going to create a different enum. So I'll use the same syntax. It's just going to be different words that I'm going to put in there. So we'll have enum list. And in there, I'll have two values, const and nil. Now, this is from the documentation, and apparently this is kind of inspired by Lisp. Never used Lisp in my life, but in Lisp there is a thing, I think it's, what's it called, a const. Let me check my notes. Yeah, in Lisp there's a thing called a const cell, which is basically very like this. It's a thing that can store a pair of values. And in Lisp, although this is absolutely crackers, if you want an actual list of things, you could do that via a recursive definition. So here I can make this const value, const is short for construct, and let's say that here this stores an I32, and it also stores a list. So now, because a list has got a list in it, and the const values have numbers in as well, I could effectively use that to create a kind of recursive structure which we could call a list. That seems like an extremely unwieldy thing to do. Maybe it somehow makes sense in Lisp, I don't know. Actually, I do have some tangential acquaintance with Lisp, which is that I once worked on a language that I'm not going to name, which was horrible, and it was apparently heavily inspired by Lisp, and it was just grotesque. I'm not even going to tell you what context this was, but I had a job working with this language. One of my colleagues once pointed out that you could type 2 + 2 and it would think for like 30 seconds before giving us the answer. And the keywords for like defining an object or something were about like, well, they were like 3 words long, like 20 characters. So that hasn't given me a good impression of Lisp. But anyway, I'm sure it's great. That wasn't Lisp though. So to get back to the point here, how would we now use this to construct a actual list of items. Let's say I'll call this values again equal. So I'd have to say list : cons, and in there I could put a value that I want to put in a list, like 3, and then for the second item we would again have list : cons, and then we could put in 4 maybe, or whatever we like, and we could have another one if we want, like list : well, this is going on a bit long. You get the idea anyway. It's a recursive thing. To finish this, instead of writing list : cons and more stuff here, instead of that, I can just use list : nil, because that's not a recursive thing. I don't have to define anything else as part of nil. So you might think that this would work in Rust here. Well, actually, I probably wouldn't think it would work, because this looks pretty strange, a recursive definition of a type. Anyway, it doesn't work. Let's go to the console and see what error comes up. I'm going to run cargo format just to be sure that I've got the formatting of mismatched closing delimiter. I've already messed something up here. What have I done? Yeah, I think I missed off a bracket here, haven't I? Yeah, it looks like it. Okay, let's try that again. Yeah, cargo format is okay. But if I actually try to compile it with cargo run, yeah, we get this error, which is in the write-up that you can see on blog.caveofprogramming.com. We get this recursive without indirection problem. But we can actually fix this using a box. Why I'd ever want to do this, I don't know. I don't think I would want to do it. It seems unlikely, unless maybe it's helpful in creating like a tree type structure or something. But there's probably other contexts where this makes more sense. Anyway, what we can do is, instead of putting a list in a list, I can put a box of list in a list, which I think looks like this. So that's the actual type. Now we've got box of list. And then this thing here, instead of storing a whole other list, now only stores a kind of smart pointer to a list. So it just stores the location of this other list. And that enables Rust to figure out the size of this, which otherwise it could not do. If you've got lists within lists, no way to figure out the size of it. But if there's just a box within the list, which happens to refer to another list, then this then has a fixed size, and Rust is happy with it. So we have to change this line down here as well. Definitely going to have to change this. Let's put box : new and wrap this whole thing in that. And let's take a look and see if that works. Clear the screen. Yeah, that doesn't work, but why not? Expected box list found list. Oh, yeah, it's complaining about this list nil. I suppose they all have to be wrapped in boxes now, do they? Probably. Let's make that a bit smaller. And here, let's say, put box : new there and wrap this as well. Why would that have to be in a box though? Maybe it does because it's part of cons. So it's that we're referring to. We're filling it in with list nil. So I suppose it also needs a box. Okay, let's try that. See if that works. Almost, by the looks of it. What's this? Variable other should have snake case name. That's from earlier on. I didn't even notice it. Really? Snake case here? Quite surprised. What I could just do here is put like an underscore in there, and that would probably make it happy. Yeah, so now this whole thing actually works. And we can use this size thing here to actually check the size of the list. It seems like I was kind of hoping that there would be a really simple way of figuring out the size of a list, because one thing I was sort of hoping is that Rust would be kind of like C or C++, where it's generally very easy to figure out the size of a thing. And here it seems with enums, it's not that straightforward, but it isn't really complicated like it would be with some languages. I don't know, maybe Python. So you are relatively close to the hardware, but the size of a list, it depends on the sizes of the values that are associated with the list variants. These are called variants apparently. It depends on how many values are associated with each variant. Apparently it's got to be big enough to fit the size of the thing's got to be big enough to fit the largest value that you have in there. I don't quite understand how this works. And there's also a discriminator that specifies which value is actually being used. and that's going to be 1 byte up to 256 different variants. So it's not a totally straightforward thing. But anyway, I want to take a look at the size of a list. I think if I put that in there, make this empty, we should be able to get the size of it. Let's take a look just out of curiosity. Okay, I've got to apparently put some colons in there. This syntax I don't understand yet. Let's try that. Yeah, so it's actually 16 bytes. So it's relatively small. Why 16 bytes? Not completely sure. I tried changing different values to different types and to see if I could actually figure out how the size of a list is calculated. I didn't really succeed, but with a bit of persistence, you could probably figure that out. So that's it for this video. This is pretty straightforward, I think, and this is a kind of smart pointer. If you want to see my write-up of this and the code as well, it's going to be on blog.caverprogramming.com. I'm going to put the video there also. And next we'll go on to whatever's next in the Rust documentation, which I presume is going to be more smart pointer kind of stuff, but we'll take a look. There is that syntax where, for example, if I remember correctly, if you want to return a result from main, which you are allowed to do, we have that thing with a box and also the dyn keyword. So now I understand box, and it's way simpler than I thought it would be. I still don't understand the dyn keyword, so I'm hoping we're going to get onto that soon as well. Until next time, happy coding.